Welcome to our today's session. It's a continuation of homogeneous equations, and we're going to look at a number of examples. Homogeneous equations. Just to remind you, we said an homogeneous equation is an equation where all the terms have the same units, both in the left side and on the right side. And therefore, going straight to the first question, we are going to read together. The pressure P of an ideal gas of density ρ is given by the equation. P is, you're given that equation there, where C is the speed. Use base units to show that this equation is homogeneous. Straight, let's do this one. Let me do this one very fast. We are saying that pressure is given by a third ρ multiplied by C squared. Therefore, I'm going to show that the units here are the same as the units on the other side. Beginning with this side here, the one for pressure. How do we get pressure? Pressure is given by force over area. What are the units of force? Force is Newton. What are the units of area? Meter squared. Now, just to remind you that Newton is the same as kilogram meter over second squared. And this means what? This means if I substitute this one here, if I substitute this one up here, now I will remain with what? I'll have now kilogram meter per second squared. Then I bring this one down here, which is the m squared. So I'll have to cancel something here. Cancelling this one and this one, I'll remain with 1m. And therefore, I'll have the final answer as kilogram. I'll have the final answer as kilogram over m s squared. So this is the units of pressure. That is the left hand side. Let's quickly go to the right hand side. Now, I will use a different pen. So the right hand side, we have a third times density times c squared. What are the units of density? Density is given by mass over volume, and the units of this one, units of mass, is kilogram over meter cubed. Then what are the units of speed? Speed is given by distance over time, and therefore the unit is meters per second. But remember, we are squaring, so I square this one, and I'll have it is kilograms meter squared over meter cubed, then s squared. Now I'll have to cancel meter squared, will cancel with meter over this side, and I will remain with a single meter here. Therefore, final answer will be kilogram then over meter per second, meter second squared. Now this unit here, you realize these units and these ones here, they are the same. And therefore, I say this equation is homogeneous. homogeneous, then homogeneous. It's homogeneous. Now let me look at another example. As per my questions over here. Question 2. The period T of a pendulum of mass m is given by the expression T is equal to 2 pi square root of I over mgh, where g is the gravitational field and it's given by force over mass, and height is the length. Determine the base units of the quantity I. Again, now let me come here and do this other question here. Now I will do it over here. Given that T is given by 2 pi, then square root of I over mgh. We are interested on I, the base units of I. So what should I do? The first thing, I need to divide everywhere by pi. Divide by 2 pi. Divide by 2 pi. So divide by 2 pi here. Divide by 2 pi. Divide by 2 pi. Then this one will cancel. I'll remain with what? Now t squared, t over 2 pi is equal to square root of root I over mgh. What should I do next? I have to square now. Square everywhere, square here, and then I square on the other side. Why am I squaring? To remove this square root over here, and therefore I will remain with this square will cancel with this square root. So I will remain with t squared over 4 pi squared. Don't forget we are squaring everything inside this bracket here, and therefore this one is equal to I over mgh. Don't forget we are interested with our I, therefore I cross multiply. Now I'll have to cross multiply. I cross multiply this one there and then this one here. Now I'll have, therefore I'll have I is equal to t squared mgh over 4 pi squared. 4 pi squared. Now, what are the units of time? The units of time is s, seconds. So this is seconds squared. What are the units of mass? Kilograms. What are the units of gravity? Is meters per second squared. Then what are the units of height? Meters. And therefore, in this case, I'll have the final answer. Something must cancel here. This will cancel with this, and therefore I'll remain with now the final answer for I, the base units of I. The base units will be, I've remained with kilogram, then meter squared is the base units of I. Very important. Now Let's go to the next question. This is very important. Please take note of this. Take note of this. Take note of that. Good. Let's go to the next question. The next question says, determine the base units of work done and 2 moment of force. This question 3. Question 3, and I'm going to do it here. This question 3 now. Work done and moment of force. Now, question 3. Question 3. A. Work done. Work done. Work done. Work done is given by force times distance. Now, what are the units of force? Newtons. What are the units of distance? Meters. But remember, I told you Newton is the same as kilogram meter over s squared, and therefore times meter, and this will remain with kilogram meter squared over second squared. That is the first one. Then I go to the other one. Moment of force. Moment of force. Nice. Moment of force. Moment of force. The second one. Moment of force number 2. How do we get moment of force? Moment is given by force times perpendicular distance. Again, force times perpendicular distance. Again, what are the units of force? Newtons. And units of distance is meter. Therefore, this is the same as I write kilogram meter over s squared times meter. And finally I'll have this as the answer, that moment of force has the units as kilograms meter squared over s squared. That tells you something, that the units of moment of force and the units of work done is the same. Let me do the other question very fast. Now we are in question 7. State the SI units of volume. The SI units of volume is meter cubed. That one I am pretty sure you know. Then you are told, show that the SI units of pressure is kilogram per meter second squared. Let me do it this one here. We have said this question 7. So 7 again. Question 7. This question 7. The first one, we are saying the units of volume is meter cubed. And now we want to show the units of pressure. Pressure is given by force over area, and the units of force is Newton, and the units of area is meter. Don't forget that this is the same as kilogram, the same as sorry for this. Just a minute. Oh, sorry. Add something. No. So don't forget that. Let me wrap this one here. Clean this one and this one. Nice. Thank you for your patience. Don't forget, Newton is the same as kilogram meter per second squared. And therefore, substituting it here, I will have finally as, I'll have my answer as kilogram meter over this meter. This should be meter squared. This should be meter squared there, over over s squared meter squared. Then I will cancel. We will have something cancelling. This meter and this one will cancel, and I will remain with 1 meter here. And therefore, I will have, finally, I will have my answer as kilogram over meter second squared. Therefore, we have shown. Let's go to the other question, part 3 now. Part 3 says, this part 3, the volume V of liquid that flows through a pipe in time t is given by the equation V over T is equal to pi p power 4. Let me write this one here. I'll write here. We are saying that V over T is given or is equal to pi p r power 4 over what? Let's go to the next one. Over 8cl over 8cl over 8cl. Let's continue. Says where P is the pressure difference, and R is the radius, L is the length. The constant C depends on the frictional effects of the liquid. Determine the base units of C. Very good. We are interested with the base units of C. So our interest is C. Don't forget that one. Our interest is C. So that means I have to make C the subject of the formula. How do I do this? I cross multiply. This I cross multiply there. And this I cross multiply here. And therefore I have V. Now I'll have, let me use a different pen. I'll V multiply by 8cl is equal to pi p r power 4 t. Good. Remember, I want C. So what should I do? I divide everywhere by 8VL. Divide by 8VL. Take note that this will cancel this, 8 will cancel this, and V will cancel this, and therefore I will remain with C. Therefore I will say C is given by or is equal to pi p r power 4 t over 8 V L. Very good. Now we need the base units of C. So what should I do? Let's start again, taking a different pen, and I will say, what are the units of pi? Pi is a constant, so it doesn't have units. P, what are the units of P? P is pressure. So what are the units of P? Pressure is given by force over area. Okay. Times. What are the units of R? R is in meters, so meters power 4. What are the units of T? T is the time taken, so it is S. This one over, but remember this one, for this one, okay, over 8 multiplied by, no, 8 does not have units, so I will cancel. What are the units of volume? Meter cubed. And what are the units of L? Again, is times meter. So ideally, even before we go further, we can cancel this. I will have this and this and this. They will cancel because this meter power 4, meter power 4. So now I will remain with this and this. Now, what are the units of force? Is Newton. The units of area is meter squared. Then times S. But remember I told you something. Remember I told you this is the same as kilogram meter over S squared. That is for Newton. So if I substitute, I'll have now kilogram. Now after substituting, I'll have kilogram meter over S, this one now squared, over S squared. Then we have this meter squared. Then we have this S. S is of course on top here. Please take note of this. This Newton is the same as this part here. The same as this part. This part is the same as Newton. Then this meter is for the area, and this S on top. So a single S will cancel. We will have something cancelling. This one will cancel with this one. After cancelling, what next? This meter will cancel with a meter here. So down here I will remain with S meter, and therefore the final answer will be just a minute. Yes, so the final answer, my units of C will be units of C. Therefore the units of C will be, therefore it will be equal to kilogram, of course this is what we have up there, then over meter S, kilogram over meter S, a symbol of this. This is the unit of C. Please take note of this. It's also very important. This is very important. Very good. Let's go at the last question. Let's go and do the last question. Yep, the last question. Yeah, again, sorry for that. Back to the last question now. Last question says, where is the last question? Let me check. Just a minute. Yeah, here is the last question. Two of the base units, the SI base quantities are mass and time. State three other base units. Base quantities, I mean, we have mass, we have time, we have electric current. That's question 9. Let me do it here. Question 9. It's question 9. Question 9. Number 1. We have electric current. Then we also have we have amount of substance. We also have temperature. We also have length, etc. There are many. So let me go to the second question. Second question is asking a sphere of radius r is moving at a speed of, or rather at speed v through air for density, that one. The resistive force F acting on the sphere is given by this one. Okay, so let me write this one, please. Let me write this one. F is equal to BR squared. So this is the second one now. That F is given by BR squared rho V power K. That is our equation. Next. Yes, where B and K are constants without unit, state the SI base unit of force, density, and V. V is the speed. So the base unit of this one, the base unit of force is Newton, which is actually the same as kilogram meter per second squared. The one for density is kilogram per meter cubed, and the one for V is meter per second. Thank you. The last question, you are told what? Then after that, after determining that, now use base units to determine the value of K. We want K now. This is a bit critical. I want you to be a little bit careful and listen keenly. So now I will have this is the last part. And we are saying, look, we want V. So let us first make V. Remember, force is given by B R power 2 R squared rho V power K. Now I want to be left with K on this side. I mean V on this side. So what should I do? Divide by B R power, R squared rho, divide by B R squared rho. So after that, what should I do? Next, now something must cancel here. I want you to observe keenly. This will cancel this. This one will cancel this, and this will cancel this. So I will remain with V power K is the same as, what are the units of force? No, okay, let me just write it as it is. Force over B squared, BR squared, then rho. What are the units of force? I have just written up them here. They are here. So they are here. So I can just pick them and bring them down here and say, therefore I'll have kilogram, okay, meter per second squared. Now divide all this, divide what? This or this, because this is the force. I'm going to divide this one, divide this one, or this over B. B is a constant, so it doesn't have units. So divide meter squared, and then density. This one multiplied by density. Density is kilogram over meter cubed. Good. Can I simplify something over here and say this one, first this one, they will cancel this one, and I will remain with M here only. And therefore I will remain with something here. That, taking it down over here just for your clarity, come here and say I'll have now this same as kilogram meter over s squared divide kilogram over m, kilogram over m. So what next? Now I'll have to simplify this further and say this same as kilogram meter over s squared multiply. Now this one changes and this one will be m over kilogram. Thank you. And then I will say something must cancel here. This kilogram will cancel with this one. And therefore I will remain with, I want you to take note of this, I will remain with V. I will remain with now meter squared over s squared. Remember this one is equal to V power k. Now I can simplify this further and say this meter over s squared is equal to, what are the units of V? Units of V is meter per second power k. And therefore I will say finally now I have my value here. I'll say k, therefore I'll say now k is equal to 2. And that is what you're expected to get. And I think with that information, you are good enough to go. If in case you have any other question, feel free to reach out to me when in school or even via my WhatsApp, please. Thank you. Have a wonderful day. Bye.